what's going on here, guys? Um, having another breakthrough with this type of technology. I now sell the large transmitter kit due to breakthroughs with technology. I now sell the large transmitter kit, which is all plug and play, for $200 plus shipping, and I sell the smaller one for $150 plus shipping. And you can contact MTech Industries 2022 at gmail.com to order. And as far as I know, this is some of the most revolutionary stuff that you can get your hands on. The system right now, in theory, can become self-sustaining with the correct circuitry. So all we have here is a receiver coil built identical to the transmitter, minus the ball, because the ball would actually detune it. For some reason it works the best without the ball. All we have is a ultra-fast bridge rectifier soldered to the receiver coil. And you can't see it, but under this Kapton tape, this white Kapton tape, is a coil identical to this one. This is just yellowish clear Kapton tape protecting it. That Kapton tape is down there. I have different types of Kapton tape. In theory, the Kapton tape should also enhance the dielectric field of the wireless power. So anyway, we take that DC that the receiver coil receives, and we turn that. We have it power up this little DC to DC boost module, and this thing will kick out anywhere from 0 to 100 volts DC. It's tunable, and we could use that to charge a battery and run an inverter, but the way you'd want to do that is run it in pulses. We need a small cheap pulse circuit to do that too. So anyway, I'll just show you the distance between those. The distance between those and the efficiency is insane. We are at a distance of 15 inches. So, like I said, you can see this module. There's nothing hidden under it. It just takes the DC. It's a DC to DC boost board. It's connected to the receiver coil, which is about 15 inches away. And here's my voltmeter. I'll connect the output to, and I wish I could be further back so I could get everything in frame, but now I will connect this boost board to my voltmeter. Hopefully you can see that. I have to keep things far apart for the optimal effects to occur. So what's occurring is we're transmitting wireless power that's at a high frequency harmonic of the Schumann earth resonant frequency. And because of that, this is an open system, not subject to the laws of thermodynamics. It's an open system receiving extra power from the Earth's ambient RF electromagnetic field. Let me repeat that. This is an open system now, not subject to the laws of thermodynamics. In theory, it should be completely self-sustaining because of the frequency we're at that's tuned in to the Schumann resonance. So, I'll turn the power supply on, this DC supply, which is a 0 to 100 volt DC supply that powers the transmitter, and then we wirelessly power our receiver coil, which we will take a reading on from the voltmeter. As you see, I can just barely turn this on and watch it charge up. As you see, our receiver circuitry will now become powered on. So we are using a fraction of a watt. Our transmitter is using 1/3 of a watt. And we're able to wirelessly power this board. As you see, the light is on. Here's our receiver coil. Maybe I can turn this sideways a bit. And if I were to interfere with the coil, the board would shut off. The light should be going out now because of the bleed off resistors on that board. And I'm just holding the coil and detuning it. I let go, it'll charge itself back up. Again, I'll demonstrate that and repeat that. Light slowly fades out due to the bleed off resistors built into the board. And this board, when it's at full power, can fry your fingers. You gotta be careful. So anyway, I'll turn it up right to about 1 watt. Right under 1 watt, just to show you the efficiency. We're using less than 1 watt of power. It's right there. We're using less than 1 watt of power. We have 33 volts output, almost 3 times the voltage output from this board. And people go, oh, you have no amperage there. Well, that's completely incorrect. We have very respectable amperage. And I even showed that in my older video. And notice how there's very little change, too, on the input of the meter. I bet you this will overload my milliamps. So we have 73, 74 milliamps. Right now, that this output power appears to be equal, if not greater than the input. And something else you can do too to massively increase the output power is you can take a lead here. You connect this to the receiver coil's earth ground, which is the bottom of the coil. You connect this to an earth connection, like the black on your power supply. Now this is what we got. Dead simple circuit. And we just doubled our current. Look at that. We have double the current. We're still using less than 1 watt of power. Using less than 1 watt of power, under 12 volts, transmitter is consuming 84 milliamps. Our output is 133 milliamps at, and this charges up. This is why you would use pulse circuitry. So to sum it up, all we're doing is we have the receiver coil grounded into the DC power supply. It's still technically wireless, it's just sharing an earth ground connection, which boosts the power and lowers the resistance of the wireless circuit. And we can even run a motor off of that. This should start up. One watt might not be enough to wirelessly run it. Okay, I'm gonna have to turn it up a little bit. Keep it at under 2 watts. Okay. Maybe 2.5. Okay, so we have a motor spinning while using less than 3 watts of power, and we're transmitting that wirelessly at a pretty respectable distance. These types of efficiencies should be impossible. Okay, there we go. We're at less than 5 watts transmitter power, and we're running a motor. And this is a pretty beefy motor. Like, this is nothing to laugh at. Less than 5 watts, we're doing that. I'm gonna back up, give you a view of everything. Everything fights me too when I film one-handed. As you can see, that's the receiver coil. The motor's spinning away happily. He gets a boost in power by just grounding one leg of the receiver coil. You don't need the meter on, or even up here, the meter's in the way. So here's the wireless power system running a motor happily, and we still have wireless power too. That can be made manifest in these little lights. Motor running along happily. And check this out. Still have the radiant energy effects. No degradation. And I can light up an unlimited amount of these. Now the optimal way to use this would be to use a pulse timer circuit. So what would happen is you would maybe charge a large capacitor or a battery in pulses, and you would have to use that energy accordingly in a certain time period. You would have to use it in a time period where the pulses charge it quicker than you discharge the power you're using. So he's running along happily. We still got wireless power. I can touch this here. It gets bright. And even when I do this, because I'm better grounding it, the motor runs a little bit faster. Now all these kits come plug and play. You get a little mini DC power supply to run it. You get 3 of these lights. And like I said, due to refinements in the technology I made, and due to parts cost coming down and breakthroughs, big one is 200 now, and the small kit is 150. And you will have to pay $30 or $40 for shipping to get them. So either way, it's like $180 for the small kit and $230 or $240 for the large one when you include shipping. And this motor's still spinning away. We'll turn it up a bit, right to under 5 watts. I mean, these types of efficiencies at this range should be impossible. And he's spinning away even faster now. This is a pretty decently torquey motor too. He's spinning away happy. Transmitter's consuming less than 5 watts. We still have insanely impressive wireless power. Radiant energy effects are still present. So yeah, that's what I wanted to show. And here, look at this. Whoa, that's spinning a lot quicker when I do that. That's funny. And our power actually went down. How crazy is that? This RF is just everywhere waiting to be harvested. So yeah, that's what I wanted to show. This technology is getting very remarkable, and thank you to all those who support me. You can feel free to help fund this technology on my page's links in the description. And if you want to purchase a kit, feel free to reach out to my email that's listed in my page's description. Like I said, all kits come plug and play. 200 for the big one, 150 for the small one, and an extra 30 or 40 bucks for shipping anywhere in the USA. And thanks again. I'll shut this off. And everything shuts off because the power supply powering the transmitter is off. And yeah, that's it. Everything's off. Everything's out. And the reason this glows very dimly is because these RF diodes are picking up something, some kind of ambient signal, and converting it to just enough light so you can see it. That's a new project I'll have to get involved with eventually when I have the time, is a special type of array of these diodes mixed with antennas that receive true free wireless energy from the environment. But yeah, thanks again. And if you want to purchase a kit, you know how. Contact me in my page's description, my email. If you want to help fund this tech, you can do that too. Like, subscribe, and thank you for all those who support me and believe in this work. Thank you.